So our challenge is to take a decimal number, such as 3. Let me just add that as a comment, and produce or convert it into its binary equivalent. So in this case, if we were dealing with 3 bits, it would give us 0, 1, 1. Now, let's begin by making a little function called convert. Let's call the function down here. And obviously make sure that this line, which is calling the function, is not inside the function. A big mistake that many beginners make. And have a little heading which says convert. Let's call it decimal to binary converter. And then, of course, we would like to take a number from the user and by default this was going to be a string input, so I'm going to cast the input into an integer. Open brackets, int over there, and don't forget to close the brackets. Great. So now I would like some sort of binary output rather. So we've been learning, or hopefully you've been learning, about mod, the mod operator, which is that in Python, and floor division, which is div. And these are two really, really powerful, really exciting operators which allow you to do all kinds of things. So for instance, if I said b for binary, you could call it anything you like. I'm just going to call it b. This is a variable called b. And into that variable, I would like to take the number and mod it by 2. Because of course we're trying to find the remainder. And we will either get a 0 or a 1, because we're modding it by 2 and we're looking at whatever's been put in, such as 5 or 3. So we get that, and if I print b, just to test what's going on so far, you can see that's quite promising, but of course it's only doing it once. So what's the next step? You might want to pause and think, now how could you use the floor division, the div operator, to do the next step and to get closer to the solution? Right, so one of the first things we want to do, instead of printing b like that, we would like to add it to a list. So I'm going to make a little empty list called answers, and at this point I'm going to take the value of b, that's a variable which is storing either 0 or 1, and append b. And just down here I'm going to take answers and reverse the list so it prints out in the correct order, and of course I could print that. So far, if I put in 3, well, we're just getting 1 bit over here, and it looks promising, but we don't know if it's going to work. Now, if you did have a think about what the next step would be, it's this, that you take the original number that the user gave you and you div that again by 2. Now, of course, we would like another bit. We don't just want the 1, we would like another bit, at least 2 bits. So I could just copy this whole thing, and let's experiment and think about what happens here. So you can see that that is appearing to work perfectly. If I put in a 2, we know that that's a 2 in binary, which is great. And if I put in a 1, that's a 1 in binary. But what would happen if I put in a 4? And you can see that doesn't quite work. And the reason is we don't have enough bits being output. So what if I copied that again? I've copied this now 4 times, which is going to give me up to 4 bits. And you know that in 4 bits you should be able to store the number 12. That's 8 plus 4 is 12, or I could write the number 8. What's the biggest number you can store in 4 bits? It would be a 1 and a 1 and a 1 and a 1, which is 8 plus 4 plus 2 plus 1, which would give us 15. So I could try that, which is great. But what if I wrote 16? Again, we get an error because I don't have enough outputs. So I could copy that. Now this could get really complicated. And immediately you should be looking at this and looking at the repetition and remembering that repetition, remember the dry rule, is don't repeat yourself. So we delete all those repeats of this code. We can say we're just simply repeating these 3 lines of code. And why don't we try putting it in a for loop, and let's say up to 8. And this is going to be the number of bits, of course. And believe it or not, simple as that, we've got our solution. So if I type in 3, it's giving it to me in 8 bits. That does appear to be working. 8, that is 8 in binary. And of course, a large number like 255. And if we went above that, again, we would get that error. And that would be down to changing this number here. So we've got this. And another little tiny activity you could do if you were experimenting with this is try and write it as a while loop instead of a for loop, which you can always do. So you start, I is equal to 0, for instance, and you could say, well, I is less than, for instance, 8. And remember, in a while loop, you always need to make sure that the value of I is going up, because in a for loop, it does it automatically for you. And again, we get an answer. Everything is working perfectly, but we've used a while loop instead of a for loop.